let's do an example of a stem and leaf plot. I had one on your example handouts, but it was a huge set of data, so I'm going to do one with a smaller set, just to kind of make it a little more reasonable. So let's say I was talking about the age of let's say some politicians in a group. So if I wanted a stem and leaf plot for this data, the leaves are the rightmost digit, and then the stem is whatever comes before that. Now, since I only gave you 2-digit numbers, then my stems are just your tens place here. So we had 2, 3, 4, 5, 6, and 7. Now, regardless of if I had a point using everyone, maybe I didn't have any 40s, you still need to go ahead and list the 4 there because you're listing things above and below it. Does that make sense? So if you have to start at 2 and end at 7, go ahead and include every number between them. All right, my leaves, we just list the one spot in order. So my 2s, we had a 29 and a 28. So I'm going to put my 8 and my 9. 3s, we had 31, 35, 36, and 39. So 1, 5, 6, and 9. My 4s, we had 42 and 47. So in order, 2 and 7. My 5s, we had 50, so 0, 52, 54, and 55. My 6s, we had 64 and 67. And then my 7s, I had 3 70s, so I have to list 0 3 times, and then we had a 71. And I think I cut them off. The advantage of a stem and leaf plot is I could look at this and write down every single one of the original points. You know, I know there was a 28, a 29, a 31, a 35. If I'm just looking at a frequency table, I might know that there were 2 points between 20 and 29, but I don't know what they actually were. So there is the advantage there. You can use, you know, if these were decimals, if I had like a 4.2, you can do the same thing. You can have your decimals over here. If I had numbers like 112, 120, 107, 124, then my stems would be like 10, 11, 12, and my leaves would just be the rightmost digit. Does that make sense? Any questions about those? You can do these by hand pretty easily. If you wanted to do Google Sheets, you know, you can make yourself a table and put a vertical bar separating the stem and leaf if you really wanted to, but it wouldn't matter there. Okay. The next way we might see our data is with a dot plot. So we had the example with the 50 households. Let's make a dot plot to go along with that. We already counted the frequencies and everything. And remember we had the number of cars that we tallied up. So if you look back when we counted that, we had 0 showed up 4 times. So you literally just put 4 dots on the 0, trying to space your dots out evenly. 1 showed up 13 times, so you put 13 dots. Two was 22 times, so we would put 22 dots. Three had 7. 4 had 3, and 5 had 1. So not the most effective measure. For me, it's a lot easier to look at a bar and see how tall it is than to count dots, but you could see data represented like this. Okay, the last thing we want to talk about, I only have a couple minutes, but I think I can do it, okay? I want to talk about shape of the distribution. So I have it written out in words, but you don't necessarily have to write down all these words. A picture might do better. Uniform, if you want to write down something, I would just say frequency is evenly spread. And that's all I would write. An example would be like a histogram, where everything has the exact same height. That's uniform. There's no variation there. If it's bell-shaped, really what you need to write is the highest frequency occurs in the middle. And then it just gets smaller as you go out to the sides. Skewed right, all you really need to write is the tail to the right is longer. So I have some data, and I have my peak. And you can see that, I have a few cases to the left of my high point, but as I'm going out to the right, I've got more. The tail goes off to the right. And skewed left, the tail to the left is longer. So you've got your center, you've got a little bit to the right, but you have more going out to the left. Okay. So this is really the end of this section. I know we only have a couple minutes left.